Hello and welcome to the PAC Workshop. We hope that the information that we present in these segments, when used along with the new PAC exam study guide, should really help you get through the exam and increase your knowledge and skills. Let's get started. So we're going to talk about pesticides in general, everything you ever wanted to know. We'll talk about laws and regulations and different types of hazards, environmental and human hazards, and also a bit about equipment and calibration. Let's get going with the pesticides here. This should be a pretty basic review. Every pesticide has on its label a signal word: caution, warning, danger. It's pretty intuitive. Yeah, caution means be careful, warning means be even more careful, etc. But a better way to look at this is to say, okay, the greater the toxicity of this pesticide and the greater the amount of pesticide exposure, the greater the hazard to the applicator. So the more exposed you are, like mixing and loading, for instance, and the greater the toxicity, for instance, warning or danger products, then obviously it's a greater hazard overall to the applicator. So pesticides have a mode of action that defines how the pesticide is actually going to take out a pest. You have contact pesticides and you also have systemic pesticides. The key differences here is that with a systemic pesticide, the insecticides are actually absorbed by the plant and transported through the plant. The pest feeds on it, and then it takes out the pest after the pest consumes the plant itself. With a contact pesticide, the pesticide has to literally directly contact the pest. A good example of that is fungicides stopping germination of pores, and it has to come into direct contact with the pest, as opposed to systemic, where the pesticide is moving through the insect after it consumes the plant. How about formulation types? What does that mean anyway? It just means how a pesticide is packaged. How does it come to you as the end user? Well, it comes in active ingredient and inert ingredients. Each container of pesticides that you use is going to have those two things. Inert ingredients means they don't really do much. It's just there as a way of keeping the product in solution, perhaps. Even water could be considered the inert ingredient. Active ingredients are the actual chemicals that form the pesticide and does the damage to the pest. So there's lots of formulation types. We have wettable powders, of course, emulsifiable concentrates, solutions, dusts, aerosols, baits, granulated, and microencapsulated products. Those are all formulation types. So here is a couple examples. Wettable powders. And each pesticide container you'll see, either like WP for wettable powder, or something like an E for an emulsifiable. Any one of those formulations that we just went through is going to have an abbreviation on the pesticide label. So in the case of wettable powders, what are some of the good things about that? What are the advantages of wettable powders? Well, it mixes well. It mixes well with other pesticides. And a real bonus is that you can get these pesticides sometimes in water-soluble packets. That's great news because it's much less hazardous to the applicator who is mixing and loading this product. Remember, the toxicity of a product has to do with how much the applicator is risking exposure to it, while water-soluble packets definitely decrease that possibility. Risk of phytotoxicity is reduced. That just means that the plant is less likely to be harmed by the pesticide itself. But on the other side, with wettable powders, abrasiveness is an issue. And that means that it can cause a lot of pump wear. It can cause nozzle clogging and wear. And the way you fix that is to use a tank agitator. So remember, with wettable powders, you've got to use that tank agitator in order to keep this product in suspension and settling out inside the tank where it's going to do some damage and lose its effectiveness. So here's some more formulation examples. We talked about the E for emulsifiable and EC for emulsifiable concentrate. What about the number? Take a look at that product label sample there for Buctrel, 4EC. Okay, EC, it's an emulsifiable concentrate, great. But what does the 4 mean? Well, the 4 simply means that there are 4 pounds per gallon in a container of the active ingredient. It's kind of handy to know that, and every time you see that number in front of a formulation like that, that's what it means. So in this case, we have 4 pounds of active ingredient in this container of Buctrel. You see inert ingredients is circled down there in red, but above that you'll see the active ingredients, of which we have 4 pounds. So if you have a 2-gallon container of 4-EC herbicide, how much active ingredient would you have? Okay, let's all do the math together. That's right, 8 pounds per gallon of active ingredient, or AI. Piece of cake. So what about adjuvants? What are they anyway? Well, they're a bunch of things. We use a lot of them. R11 is used a lot here in Napa, and it's just a substance that is added to a spray to enhance performance. So it just improves that pesticide mix in some way. And here's some examples of the ways that it can do that. It improves wetting ability of certain solutions, droplet deposition. It can adjust the pH of certain solutions, and it actually can improve penetration of solutions through plant and insect cuticles. That's a pretty important trait there. If you can actually improve penetration, say for instance in a contact type of pesticide, that adjuvant would certainly be a welcome one, because you have to completely directly cover a pest with pesticide. And but insect cuticles, or they're hard outside parts, they're a little bit hard to absorb pesticides through in some cases. So we can use all the help we can get. Here's one that should be very familiar to you. Everybody has heard this said probably 100 times. The label is the law. It literally is. A pesticide label is a legal document which describes what kind of PPE you must use. What are the specific directions for use? How can I store and dispose of this product? First aid measures and precautionary statements, all of that is in the label, of course. So the way to look at that, when you hear that statement, the label is the law, it literally is that a legal document, and it's not necessarily the way you might have thought about it before, but you'll want to think about that way from here on. Well, if the label is the law and is a legal document, what in the world is an SDS, a safety data sheet? Well, it's a big difference. In fact, they're really not that similar at all, even though an SDS is going to have PPE recommendations in there. It might tell you how to, what are the best way to pick up a spill, what materials to use, et cetera, et cetera. The safety data sheet is more about providing information about the chemical itself. For instance, what type of firefighting methods might you need to use? And of course, you're probably getting the idea here that an SDS is kind of like more what first responders would use if encountering this pesticide, maybe a pesticide spill out on the highway or something like that. It tells you about the stability and the reactivity of the chemical itself, the pesticide. It tells you how to safely transport that. What placard do you need to put on the transportation vehicle, and also disposal considerations. So for you, you would never want to get PPE requirements and things like that from an SDS. It's more about chemical problems associated with a chemical, stability, reactivity, firefighting, that type of thing. Still, you need to have them, so we need to know what they are. And I should also mention that SDSs are really standardized. There will always be 16 sections on an SDS that will tell you about all of these different things. It's an interesting read, but don't assume that it's the same as the label. In fact, they sometimes have a different signal word. Something that on the label is described as a caution product might be a warning product under the SDS. So it's a little tough, it can be confusing, but just remember that the label is the law. All right, speaking of laws, here we go. It's important that you know where these laws and regulations come from. California Code of Regulations, Title III, Division 6. This is where all of the pesticide safety and worker safety sections are found. And it's important that you know where they come from. And let's go through some examples of some regulations. Pesticide labels have to be available at the use site. Yep, they do, always. Make sure they're in good condition, meaning you can read them and it's not like soaked through with pesticide or been sitting in a wet field for a long time and therefore you can't read the label anymore. Be careful with that kind of thing. The employer has to provide PPE when employees mix, load, store, or apply pesticides. Those are all very important regulations to know. Title III, Division 6 also talks about workers being able to be notified of a pesticide application either orally or by posting. But if the label specifically says you need to post it, well then you need to post it. And it has to be in a very, very specific form. I'll tell you what I mean here. First off, posting is going to be required if the restricted entry interval is greater than 48 hours in an open field or greater than 4 hours in an enclosed space such as a greenhouse. Now take a look at the sign on the right. You might have seen a lot of, danger pesticides, keep out type of signs on things, right? But for posting requirements, it has to have these elements: the word danger, the word pesticides, the words keep out, and also that skull and crossbones. And the reason for that is because that's unambiguous. Whether the sign is in English or Spanish or both, and hopefully both, you get bonus points for bilingual signs here. That skull and crossbones is just universally understood as to mean, yeah, you wander around in here and you could become bones. So we must have that symbol along with danger and keep out. Danger, pesticides, keep out, and the skull and crossbones for official postings. Okay, Title III, Division 6 also tells you that you have to have a restricted materials permit from the Ag Commissioner before you apply a California restricted material on the property where you work. And a notice of intent, or NOI, has to be submitted to the County Ag Commissioner 24 hours in advance of that application. And if it's a fumigation, you need 48 hours for that. So here's a fun slide. This talks about transporting pesticides on the road, or in general, really. Even if it's on the farm property itself, a lot of this stuff still applies because it kind of boils down to common sense, really. So you can see in the picture that there's some drums in the front of the bed there next to the cab, and they're strapped in there nice and secure. Yeah, you bet. You've got to have them secured. You can put them in a lockbox like you see on the left-hand side there, and unless they're rolling around loose in there, that's a pretty good thing. It serves that dual purpose of keeping everybody else away from those pesticides and also having them contained safely. And always remember that you don't want to put pesticides in the back with people riding in the back, right? Or animals, or animal feed, or certainly not human food. So keep that stuff in mind. And also you can see in this picture, down leaning against the tailgate there, there's a nice little spill kit. And you really should have that material around when you're transporting pesticides. So what does it mean? What do I need to have? Well, you see the shovel and the broom and the dustpan, and you'd certainly want to be wearing PPE to do this, but keep in mind that both sawdust and kitty litter are great absorbents. Either of those two materials are really good for taking care of pesticide spills. Sometimes the label will have information on what to do in case of a spill. Certainly follow that. If not, remember that safety data sheet, the SDS, will have information on what to do in case of a spill. And one last thing, if you're going to carry around pesticides like this in the back of a truck, you don't necessarily want to keep things like pickaxes or other sharp objects back there because, well, they could damage the pesticide containers. If you have a plastic gallon or 2-gallon jug and something goes flying, the last thing you want is a punctured container back there because that could create an exposure situation. Okay, let's talk about some environmental hazards and the characteristics of pesticides. So solubility is simply the ability to dissolve in liquid. That's all it is. And the issue with solubility is that it means that a pesticide is much more likely then to move with the water in solution, and it travels in surface runoff and or it can leach into the soil. So all leaching means is the downward movement of water and anything else that's in solution with it, like pesticides, down through the soil. And obviously that could create groundwater contamination issues, and there are areas where it has done just that. So it's something to always be aware of. Volatility. It means that as the temperature rises, ambient temperature outside, well, pesticides are much more able to turn into gas or vapor. The problem with that is volatilization, which simply means that the pesticides now into a gas or vapor form can be transported by the wind, say, or just they just move off the plant. And that's due to volatility. Temperatures rise, they turn into gas or vapor, and that might create a problem with drift. There have been pretty serious drift cases recorded about off-site movement because of volatility. And lastly, persistence simply means the amount of time a pesticide remains active before it breaks down completely. So it persists in the environment until it breaks down. And drift, as we just mentioned, is just the movement of pesticide particles, spray, or vapor moving through the air away from where it was supposed to be, the application site. So there's all kinds of things that can create these conditions that would enhance the probability of drift, and that would be obviously wind speed. If the wind reaches a point where it's kind of a given that anything that you spray is going to blow off the application site, well, that's kind of common sense. But now we know from volatility that rising temperatures can also create that. And that inversion layer that we've all heard of, that definitely affects the potential for drift. In the two pictures on the right, you see what a normal pattern looks like, where you have warm air at ground level and it starts to cool the higher up you go. Well, that enhances the ability of the movement of air straight up. But sometimes you have a warm inversion layer above the ground level, and that creates kind of a turning back. It just hits a ceiling and comes right back down, but it might move sideways before it comes down, and that is the dreaded inversion layer that we never want to do applications when that is present. You may have seen other photographs of smoke from a chimney that rises vertically, and then all of a sudden you can see clearly that it goes off to the left and to the right because it literally hits a wall because of a warm layer of air above the ground level air. So let's talk about some human hazards. There's different types of toxicity, but they're, acute and chronic toxicity are the two that are most important to you. And acute toxicity is the harm that's caused by just one single event. Pesticide is splashed into your eyes and some harm is caused, or you breathe in dust from a pesticide and harm is caused. Dermal exposure is obviously, a very common type of exposure. So acute just means one and done, single event, and that's all there is to it. Chronic toxicity is the harm that's caused by repeated exposures over time. If you've been doing this line of work for a long time and you've been exposed several times, and you might have delayed reactions that can appear, days, months, years after pesticide exposures, or you can develop sensitization, which is a gradual development of allergic reaction from enduring or consistent exposures. So acute is the one that you'll hear kind of like in the medical literature as just being, it's happening right now, it's a single event, and that's the harm. Toxicity is harm caused by that single event. Okay, how about some exposure examples here? This is one of my favorite slides. We want to talk about, what are some examples of ways that you can get exposed, like we just talked about, these different types of exposures. So what you're looking at here is a livestock dipping vat. And probably most of us watching this video haven't done a whole lot of this. But if you look at that picture, you can see that the exposure risk is pretty high. So if you look closely, you'll see that this poor little guy had to go through a gate, and he's got nowhere else to go but in the soup. And when he gets out of that dip, most animals, when they get out of water and they're standing on dry ground again, what do? They shake, right? Well, look at the guy who's handling the gate. He's got on some nitrile gloves, and that's nice, but he's wearing short sleeves, no eye protection, no other dermal protection, and so it kind of shows to reason that that guy thrashing around in the vat down there or shaking when it gets out is likely to induce a splash hazard. Yeah, I would say so. And like we talked about on the last slide, you can certainly inhale dusts or spray mists. And if you're repairing or adjusting equipment, you need to remember that that equipment was used to apply pesticides. So there is an exposure risk from the mere act of repairing or adjusting it. Keep that in mind. And of course, mixing and loading pesticides, you're going to have exposure risks. And speaking of livestock and exposure problems, they dip dairy cows as well, or, they kind of spray them down with stuff because they really suffer from flies and all kinds of pests like that. And if those dairy cows are then milked, if they have residue on their skin and coat, it definitely would pose a risk of contaminating that milk. So it's just kind of not something that we see a lot of in Napa, but it's important that you know that what the risks are associated with these pesticide applications. Be careful when dipping sheep. That's all I'm saying. Okay, so equipment and calibration. Let's talk about some of the different application methods that are out there. This one should look very familiar to everybody here. Sprayers, of course, and low pressure booms. Those are great because they're going to use less pesticide, kind of common sense. If it's low pressure, you're going to be using less pesticide than if you have like this high volume, high pressure rig. And you can also direct the application using spray shields and things like that. The downside is that the nozzles are delicate. They're exposed out there, and they can be damaged during applications. And remember that wettable powder thing that's already doing damage because it's abrasive. So the nozzles require a lot of special care. And how about backpack sprayers? Well, they can certainly reach areas a tractor can't. Steep terrain, which we see a lot of, and it keeps the pesticide on target pretty well, but it's a lot of work for the applicator, and also the volume can be inconsistent because it's up to the applicator to kind of be consistent with how they swing that blower around and keep the throttle at a certain level. Yeah, so it has its uses, to be sure. Some good, some bad. Here's one you don't see every day. This is called a rope wick applicator or wiper. And you can see in the photo that this kind of like that white boom is pressurized and it saturates the rope which is called a wick in this case. So you have this saturated wick, and then you roll along in the field, and obviously the crop has to be like at ground level, some really low growing crop. And so the only thing that comes in contact with the pesticide wicks is weeds that are higher than the crop. The only downside to this really is that in theory the wick could clog or oversaturate and drip onto the crop, but there's pretty much zero drift potential using a rig like this. So chemigation is another application method, of course, and this is great because it's extremely precise and it uses a system that you probably already have in place. You're going to have to add some expensive components to a chemigation system because there's a lot of course, regulatory requirements for exactly how this is metered and check valves and all kinds of stuff like that. But chemigation does have a lot of real advantages. Bait delivery systems. The great thing about this is that you're only going to use the amount of pesticide that you need to control the pest. You're not doing some, massive broadcast of baits. So it's very effective that way and safe. But, you got to build the thing. You have to either purchase this equipment or build it yourself. And about nozzle choice. The nozzle choice that you make, of course, will affect the droplet size, uniformity of spray, the coverage, and also the drift potential. And those little charts below each nozzle are kind of neat because they show you the different spray patterns that you can produce using various types of nozzles. So how do you know that it's really working correctly? The only really, accurate way to do that is to set something out like cardboard underneath there and do a short spray. Take a look at the pattern. Does it look like what you're expecting it to look like? That's the way you calibrate those nozzles. Just checking the spray pattern to ensure that the nozzle is performing as advertised. Equipment maintenance. This is pretty important stuff here. You always want to clean your pesticide equipment at the application site. And the picture on the right here shows a very typical mix load station. Probably looks very familiar to everyone. You want to inspect hoses and fittings and the nozzles we just talked about. And then we're kind of driving it home here. Be aware that maintaining and repairing equipment is itself a pesticide exposure risk, right? And also, mixed load stations, by definition, have water around them. So be sure that you're looking out for unprotected well casings. Why? Because if you're rinsing out equipment here, we don't want that possibility for groundwater contamination. Now, if you take a look at that picture, you'll notice it's like a stanchion that comes up, hits a right angle, and then there's like a hose coming down. What is that? Hopefully, most of you know that that is a manual air gap. So the tractor pulls underneath that, and they open up the tank, and there should be a nice separation, an air gap between the end of that hose and that rim, the upper rim of the tank. The reason that we have that is because we don't want pesticide that's in the tank or any kind of mix at all to accidentally backflow back into the freshwater system. So that is called an air gap, and it is a regulation that you must use some type of an air gap. And you can get pretty creative with that, but the bottom line is that you've got to have a gap there. I should mention that if you are using a closed system nurse tank, you wouldn't need that air gap. But we don't see a whole lot of that, but it is out there. So you should just know that. But the air gap is required anytime you're trying to put water into that tank from an outside source. Okay, another calibration issue. what does that mean? It just means that you're making adjustments to equipment so that the correct amount of pesticide is applied to the treatment area. You have to be able to calculate exactly how much pesticide is going where and at what rate. So that is why we calibrate. Do we just adjust our equipment so that we get that correct amount applied where it belongs, to the treatment area? And now we do that, of course, to make the pesticide effective. We do it to protect human health and the environment. And we want to be efficient and effective because this stuff isn't cheap, right? We want to make sure we get the correct spray volume. And as I just said, extremely important to apply at the correct label rate. So what do we use to calibrate? All of these things. The stopwatch, obviously, a scale. You might need to measure out a certain amount of, powder or liquid, the graduated container for the liquids there on the right, a measuring tape, flagging tape, a pressure gauge. All of these things are things that you will need to make those calibrations. Now your study guide shows you exactly how to do all these things, but it would take me hours in this presentation to go over each and every way of doing that. So please use your study guides to go over all of the calibration methods using things like the stopwatch, flow meter, scale, etc., all things that you will need. And this is another thing where I need you to really pay attention to the information that's in your study guide, because we're not able to cover calculations thoroughly in a presentation like this. But you're going to be doing things like calculating travel speed, using swath width and pesticides amount per acre, AI or active ingredient per acre, how you calculate sprayer output into all of those things. It's actually, pretty basic stuff, not difficult to learn. So again, I refer you back to your study guides to do the math and work through this stuff. Most of it is not too hard to figure out. For example, if you're running along at a certain pressure with a certain number of nozzles and swath width, and you have a certain steady speed going on, well, what would happen if you doubled that speed? If you accidentally or on purpose were really inconsistent with your speed, you are going to be changing the application rate. Because you can kind of picture it. If you're going along and then you double your speed, your actual rate of application would decrease, right? All right, so kind of work out the logic there whenever you work on this type of a problem. Just make sure that it meets the logic test as well as doing the math. So that's it for this portion of the PAC workshop. We are now going to get into some quick label question exercises, and also, very importantly, integrated pest management for private applicators. So we'll switch over to the next slide presentation.